Greetings, universe explorers, and welcome to Eskimos. Prepare to embark on a thrilling voyage through the cosmos as we debunk 24 pervasive space myths. We'll delve into the depths of space, separating fact from fiction, and illuminating the awe-inspiring truths that govern our universe. From the fiery heart of our sun to the icy expanse of interstellar space, we'll challenge long-held assumptions and replace them with the latest scientific understanding. Our journey will take us past celestial wonders, unraveling mysteries, and igniting our curiosity about the vast unknown. Fasten your seatbelts and prepare for liftoff as we uncover the secrets of the universe one myth at a time. Our sun, a blazing beacon in the sky, has captivated humanity for millennia. It's easy to perceive it as a giant inferno, perpetually engulfed in flames. But I'm here to tell you, that's a misconception. The sun's immense energy output isn't a product of chemical combustion like a bonfire. Instead, it's the result of nuclear fusion, a process far more powerful and efficient. Deep within the sun's core, hydrogen atoms fuse together, creating helium and releasing an astonishing amount of energy. So, the next time you gaze upon the sun's radiant glow, remember that you're witnessing the awesome power of nuclear fusion. We often think of Earth as a uniquely privileged planet, blessed with the life-giving elixir of liquid water. This perception is understandable, given that over 70% of our planet's surface is covered by oceans, lakes, and rivers. Water is essential for all known forms of life, and its presence has shaped the evolution of our planet in countless ways. And while it's true that Earth harbors vast oceans, it's not the only celestial body where water resides. In our quest to understand the cosmos, we've discovered that water is far more widespread than we ever imagined. From the polar ice caps of Mars to the icy crust of Europa, one of Jupiter's moons, water is a common thread that weaves through the fabric of our solar system. In fact, water is surprisingly abundant throughout the universe, albeit often in frozen or gaseous forms. The cold, dark reaches of space are home to vast quantities of water ice, locked away in comets, asteroids, and the frozen surfaces of distant moons. Even in the scorching heat of stars, water vapor can be found in the outer layers of their atmospheres. From the icy rings of Saturn to the vast molecular clouds drifting through interstellar space, water molecules are found in surprising abundance. These molecular clouds, composed of gas and dust, are the birthplaces of stars and planets. Within these clouds, water molecules form on the surfaces of tiny dust grains, eventually coalescing into larger bodies of ice. Comets, those celestial wanderers, are often referred to as dirty snowballs due to their significant ice content. As they journey through the solar system, the heat from the sun causes their icy surfaces to sublimate, releasing water vapor and creating the characteristic glowing comas and tails that we see from Earth. These comets are not just relics of the early solar system, they are also carriers of water and organic molecules, potentially seeding young planets with the ingredients for life. Even on planets and moons within our own solar system, we've discovered evidence of water. Mars, with its dry, dusty surface, shows signs of ancient water flows in the form of dried-up riverbeds and mineral deposits that could only have formed in the presence of liquid water. The discovery of recurring slope lineae, dark streaks that appear to flow down Martian slopes during warm seasons, suggests that liquid water may still exist on the red planet today. Europa, a moon of Jupiter, is thought to harbor a subsurface ocean beneath its icy crust. This ocean, kept liquid by the tidal forces exerted by Jupiter's immense gravity, could potentially be one of the most promising places to search for extraterrestrial life in our solar system. The presence of water in these diverse environments raises intriguing questions about the potential for life beyond Earth. The presence of water in these diverse cosmic environments suggests that the ingredients for life may be more common than we once thought. Water, with its unique properties, is a key ingredient for life as we know it. Its ability to dissolve a wide range of substances makes it an ideal medium for the complex chemistry that underpins biological processes. The discovery of water in so many different places in the universe hints at the possibility that life, too, might be more widespread than we ever dared to imagine. As we continue to explore the cosmos, the search for water will remain a central focus, guiding us in our quest to understand our place in the universe. Comets, those icy wanderers of the cosmos, have captivated skywatchers for centuries with their luminous tails. But have you ever wondered what causes these celestial plumes to form? Contrary to popular belief, comets don't have tails as a permanent fixture. These tails are a temporary phenomenon, only developing when a comet ventures close enough to a star, like our sun. As the comet approaches the star, the increasing heat begins to vaporize the ice and dust on its surface. This vaporized material is then swept back by the pressure of the star's radiation and solar wind, creating the comet's magnificent tail. The tail always points away from the star, regardless of the comet's direction of travel. So the next time you witness a comet gracing our night sky, remember that its tail is a fleeting spectacle. When we envision the vast emptiness of space, we often imagine it as a cold, unforgiving environment. In the vacuum of space, temperature is defined differently than here on Earth. On our planet, heat transfer occurs through conduction, convection, and radiation. However, in the near-perfect vacuum of space, conduction and convection are negligible. This leaves radiation as the primary means of heat transfer in space. Objects in space absorb energy from the sun and other stars, and they also radiate their own heat energy. In the vast emptiness between stars, temperatures plummet to an astonishing negative 270.45 degrees Celsius. When we discuss the vast distances between stars and galaxies, we often encounter the term light year. It's a word that sparks the imagination, conjuring images of time travel and interstellar voyages. However, a light year isn't a measure of time, but a measure of distance. A light year is the distance that light travels in 1 year. Light zips through the vacuum of space at an astounding speed of approximately 299,792,458 meters per second. To put that into perspective, light could circle the Earth over 7 times in a single second. The nearest star to our sun, Proxima Centauri, is a little over 4 light years away. In our cosmic neighborhood, we encounter gas giants like Jupiter and Saturn, colossal planets composed primarily of hydrogen and helium. These behemoths, shrouded in swirling clouds of gas, might seem like entirely alien worlds. But beneath their turbulent atmospheres lies a fascinating secret: a solid core. While gas giants are predominantly gaseous, their immense gravity compresses their inner layers to incredible densities, creating a solid core at their heart. This core is thought to be composed of heavier elements like rock and ice. As we venture beyond our solar system, we encounter a fascinating class of planets known as super-Earths. These planets are larger and more massive than Earth, but smaller than gas giants. The discovery of gas giants with solid cores and the intriguing diversity of super-Earths highlight the incredible variety of planets that populate our universe. In our solar system's grand ballet, Mercury and Venus take center stage as the 2 innermost planets. Intuition might lead us to believe that Mercury, being closest to the Sun, would be the hottest of the 2. However, the cosmos often defies our expectations. Venus, despite being farther from the Sun than Mercury, claims the title of the hottest planet in our solar system. The reason for this lies in Venus's thick and toxic atmosphere, composed primarily of carbon dioxide. This thick blanket of CO2 traps heat from the Sun, creating a runaway greenhouse effect. Temperatures on Venus soar to an astounding 462 degrees Celsius, hot enough to melt lead. On a clear, dark night, away from city lights, we gaze up at the celestial tapestry above, awestruck by the sheer number of stars twinkling in the darkness. It's easy to feel a sense of awe and wonder at the vastness of the universe. But here's a humbling thought. We're only seeing a tiny fraction of the stars that actually exist. The naked eye, while remarkable, is limited in its ability to detect faint objects. From a dark sky location, we can see a few thousand stars, but this represents a minuscule fraction of the stars within our own Milky Way galaxy. The Milky Way contains an estimated 100 to 400 billion stars, and our galaxy is just one of billions upon billions of galaxies scattered throughout the observable universe. Our moon, a celestial companion that has graced Earth's skies for billions of years, might seem like a permanent fixture, but even the cosmos experiences change, and our moon is slowly but surely drifting away from us. This gradual separation is driven by the gravitational interaction between the Earth and the moon. As the moon orbits our planet, its gravity creates tides, not just in Earth's oceans, but also in Earth's solid body. These tidal bulges, created by the moon's gravitational pull, are slightly ahead of the moon in its orbit due to Earth's rotation. This misalignment results in a transfer of angular momentum from Earth's rotation to the moon's orbit. The allure of space travel, of venturing beyond Earth's embrace and setting foot on other worlds, has captivated humanity for generations. But as much as we dream of interstellar voyages and encounters with alien civilizations, the reality of space travel is a challenging one. Traveling through the vast distances of space presents formidable obstacles. The sheer scale of the cosmos means that even reaching our closest stellar neighbors would require journeys spanning multiple generations. The speeds required for such voyages far exceed anything our current spacecraft are capable of achieving. To overcome these challenges, we need revolutionary advancements in propulsion systems, energy generation, and life support technologies. While we haven't yet cracked the code of interstellar travel, the human spirit of exploration remains undeterred. As we conclude our exploration of these common space myths, I hope you've gained a deeper appreciation for the wonders and complexities of our universe. Remember, the cosmos is full of surprises, and what we think we know can always be challenged by new discoveries. Never stop questioning, never stop exploring. There's still so much out there to discover, from the smallest particles to the largest structures in the universe. Every new piece of knowledge brings us closer to understanding our place in the grand cosmic scheme. Until next time, keep exploring.